Welcome to Space in Minutes, where space meets simplicity. New videos drop weekly, so subscribe and join our awesome cosmic community. If you're excited about making space more accessible for everyone, why not join us as a member? Your support really means everything to us. As a member, you can enjoy our videos without ads and help us create even more awesome content. Before Earth, before the sun, before the planets, there was just this massive cloud of gas and dust drifting around in space, kind of like a cosmic fog. It's wild to think about, right? So, how did this swirling chaos transform into the orderly solar system we call home today? Let's take a trip back 4.6 billion years and follow the incredible journey from that initial chaos to the stunning creation of planets, moons, and all the celestial wonders we see. Imagine the intense heat and pressure that sparked the birth of our sun, igniting the dance of gravity that pulled everything into place. It's like the universe was crafting a masterpiece, one star and planet at a time. Welcome to Space in Minutes. Today, we're exploring how the solar system was born, from chaos to cosmic architecture. Stars, planets, moons, and even asteroids all came from the same ancient ingredients. This is the origin story of our planetary neighborhood and your own cosmic roots. It all began with a giant molecular cloud, mostly hydrogen, helium, and traces of heavier elements. Imagine a vast, dark nebula stretching across light years, quietly drifting through the cosmos. This celestial nursery held the potential for countless stars and worlds, waiting for the right trigger to spring into action. That trigger may have come in the form of a nearby supernova, a massive star exploding at the end of its life. The shockwave from this cosmic firework rippled through space, compressing part of our molecular cloud. That nearby explosion also seeded the cloud with extra dust and heavy elements, nudging it into action. As the cloud began to collapse under its own gravity, something magical happened. It started to spin, faster and faster. Think of a figure skater pulling in their arms during a spin. As the cloud contracted, its rotation sped up, flattening into a disk. This spinning pancake of gas and dust, stretching billions of kilometers across, became known as the solar nebula. It was here, in this cosmic carousel, that the groundwork for our entire solar system was laid. At the heart of this swirling disk, gravity worked its patient magic. Material clumped together, growing denser and hotter. For millions of years, pressure built up in this protostar, like a cosmic pressure cooker. Then, in a moment that would change everything, nuclear fusion ignited. The sun was born, blazing to life at the center of our forming solar system. It wasn't an instant process, though. It took around 50 million years for our star to stabilize into what astronomers call a main sequence star. As the sun found its rhythm, it began to flex its newfound power. Powerful solar winds billowed outward, clearing the central region of the nebula. Lighter materials were pushed to the outer reaches, while heavier elements remained closer to the star. This cosmic spring cleaning played a crucial role in shaping the young solar system. Picture a massive bonfire suddenly lighting up in the center of a dusty field. As it roars to life, smoke and ash are pushed back, creating a clearing around the flames. Our young sun acted much the same way, carving out its own space in the heart of the nebula. While the sun was busy being born, an equally fascinating process was unfolding in the disk around it. Tiny dust grains, no bigger than specks of sand, began to stick together. These cosmic building blocks grew from pebbles to rocks to planetesimals, the seeds of future worlds. It was a chaotic time, full of collisions. Some impacts shattered objects apart, while others fused them together into larger bodies. These rocky seeds, after countless collisions and combinations, evolved into what we call protoplanets. Can you believe it? Yes. Some of these little guys transformed into the massive gas giants we know today, like Jupiter and Saturn, scooping up gas like a vacuum before those solar winds could sweep it all away. Meanwhile, Others became the rocky inner planets, our very own Earth, Mars, Venus, and Mercury. It's fascinating to think about how each of these planets developed their own unique characteristics, right? Earth, with its life-sustaining atmosphere, Mars, with its mysterious red dust, and Venus, often called Earth's twin, but with a totally different vibe. It's like a cosmic story of survival and transformation. Imagine trying to build a city out of floating rubble in space. Gravity acts as the architect, pulling pieces together. Time serves as the patient construction crew, allowing millions of years for these cosmic Legos to assemble into worlds. That's essentially how our planets came to be. But planets weren't the only worlds taking shape. Moons formed too, often from leftover debris or massive impacts. A whole moon may have been born when a Mars-sized object slammed into the young Earth, throwing up a ring of debris that eventually coalesced into our celestial companion. As the solar system took shape, something really fascinating happened. The inner planets, Mercury, Venus, Earth, and Mars, ended up being these small, rocky worlds. On the flip side, the outer planets, Jupiter, Saturn, Uranus, and Neptune, turned into these gigantic gas giants. So, why the big difference, you might wonder? Well, it all comes down to where they formed in the solar nebula. The inner planets formed closer to the sun, where it was too hot for gases to stick around, so they ended up rocky and solid. Meanwhile, the outer planets formed farther out, where it was cooler, allowing them to gather all that gas and become these massive, swirling giants. Isn't that just wild? It all comes down to temperature and location. It's closer to the sun. It was simply too hot for gases and ices to stick around. Only metals and rock could form solid objects in this cosmic furnace. But farther out, where temperatures plummeted, it was cold enough for gas and ice to accumulate. This allowed the outer planets to build up enormous, low-density bodies with thick atmospheres. Think of it like this. Try boiling water near a roaring fire, then try freezing it in a refrigerator. You're working with the same ingredients, but the environment leads to very different results. Our solar system followed a similar principle, with the sun's heat determining what could form where. Once the main planets had formed, the young solar system was anything but peaceful. Picture this. About 4 billion years ago, a wild time called the Late Heavy Bombardment hit our cosmic neighborhood like a cosmic roller coaster. Imagine leftover debris, think asteroids and comets crashing into planets and moons left and right. It was like a celestial game of dodgeball, with these space rocks slamming down with terrifying frequency, reshaping the surfaces of worlds. This chaotic period played a huge role in shaping the planets we know today, leaving craters that tell stories of those wild cosmic days. Isn't it fascinating to think about how much chaos had to happen for our beautiful Earth to form? This violent cleanup reshaped planetary surfaces, carving out massive craters and valleys. But it wasn't all destruction. These impacts may have delivered vital ingredients to the early Earth, including water and organic molecules. Some scientists even speculate that this bombardment might have played a role in kickstarting life on our planet. Eventually, the solar system found a semblance of order. Gravity did its work, clearing out much of the debris. Moons settled into stable orbits around their planets. Asteroids found homes in belts and clusters, particularly in the region between Mars and Jupiter. What emerged was the cosmic clockwork we see today. 8 planets, hundreds of moons, and countless smaller bodies, all dancing in intricate orbital patterns. But even now, that stability isn't perfect. Asteroids still wander, occasionally crossing paths with planets. Comets dive in from the distant Oort cloud, a shell of icy bodies at the edge of our solar system. Even the orbits of planets shift ever so slowly over vast stretches of time. Our solar system, you see, is not a static museum piece, okay? It's a dynamic, ever-changing structure, still capable of surprising us after billions of years. From a collapsing cloud to a system of worlds, our solar system is the product of cosmic trial and error on an unimaginable scale. It's a testament to the creative power of gravity, time, and the fundamental forces of nature. And we're just one tiny piece of it, a small blue planet with a front row seat to the greatest show in the universe. Everything you see around you, the oceans, the mountains, the air you breathe, all trace their origins back to that primordial cloud and the dusty remains of long dead stars. In a very real sense, you're made from the solar system, okay? And it was made for moments like this, when conscious beings can look up at the night sky and marvel at their cosmic heritage. So the next time you gaze at the stars, remember, you're not just an observer of the universe. You're part of its grand, ongoing story. That's just one cosmic mystery explained in minutes. If you learned something new today, give it a like and let me know what you're curious about in the comments. I'll reply to every single one. And if you want to see more space, science, and imagination, all in under 10 minutes, subscribe for more. Thank you so much for watching. I'll see you next time. That's 1 minute. See you tomorrow.